Yeah. Hello all, good morning. So let's start. Welcome everyone to the Chaos Engineering course. And today we'll be having a small introduction on the course and what all we'll be covering. What are the important key learnings you will take away from the course? So we'll be covering those things today. And we have come a long way with this course. Like it's almost, I guess, the 10th batch now, which is happening. So if I remember properly, when we started for the first batch, that time the tool choice, like because chaos engineering, if you know, it's a very new domain. So uh, the community is not that huge around chaos engineering. But when we started that time, so we faced a lot of challenges like choosing, doing a proper market study, which tools to be chosen, and the course content and all. And it's a long way now. It's almost 10th batch now, and a lot of corporate trainings also have been completed. So the course has been refined a lot from what we started long time back and what we have now. It's almost 2 years now, I guess, from where we started. Yeah. So currently, if we speak about chaos engineering, it is in a very, we can say it's in a burning state now, because if you see, almost every organization is trying to set up chaos engineering. The main reason behind that, the driving force, is the advent of cloud. Like everyone is transforming the technology into cloud, and also distributed systems like microservices and all, where chaos engineering plays a vital role. Obviously, we do chaos engineering on monolithic systems also, where we have like non-cloud systems. But the major advantage, or we can say, um, like let's say if you have 100 percentage of coverage for cloud, monolithic systems, maybe you can go till 70 or 75. So that, like, what we see is chaos engineering adds is a very field which has grown mainly due to the cloud majorly. So yeah, so let's try to understand the course and how we will progress. So let me share my screen. Yeah. So first of all, the how the course will go is, so these are the different materials which will be provided to you once you join the course. So this has like basically this material covers all those things which we are doing in this course. So you won't be needing anything from outside. Even the softwares what we will be using, all those softwares, the versions, everything is there here itself in this folder, and I will be sharing this Google Drive link with all of you, so you can access those anytime. Okay. And yeah, so now to give you an introduction on the modules. So basically, our lecture modules are divided into four: module 1, 2, 3, and 4. In module 1, it's mainly about the introduction of chaos. Like basically, if you see the introductory module, it's mainly about the introduction to chaos, the principles which are there in chaos. So if you are a chaos engineer, what are the activities you perform, right? The process, how the process of chaos engineering happens, what are the prerequisites if you need to do a chaos engineering. Because so basically, module 1 will make you ready for you to implement chaos engineering, or to get an idea what really chaos engineering is. Because in the market, if you see, there are a lot of room, like I won't say, so it's more sort of like people are not really clear what we do in chaos engineering. Okay. So that question will be answered in the module 1. So after you finish module 1, you will be very clear about what are the boundaries or borders in which chaos engineering plays, or we play around, and what are those limitations, or we can say what are the advantages we have over other testing. Why do we need this testing, this one more testing, right? Like why do we need this? Like we have already so many traditional testing practices, why we need one more extra? So what are those reasons? So all these questions will be cleared in the module 1. Then when we progress to module 2, it's mainly on the module 2 will be mainly speaking on like identifying the use cases, right? It's more sort of planning, like how you create a test plan, how you read an NFR, from that how you develop your plan, and how you implement chaos into your organization. So it's more about actioning, right? Like how you execute your knowledge, or how you execute and how you implement it in your organization. So module 2 will be covering those things. And Module 3 is more sort of action, like it's more sort of the tool, right? Like it's on the like mainly we will be focusing on Gremlin, different tools. So in when we speak about Gremlin or when we learn Gremlin, uh, what will happen is when we are doing chaos engineering, we need to understand different systems which are there in the infrastructure, or we can say in the applications. So in that process, what we will do is we will try to first see the cloud AWS, like how the cloud, how you set up an instance on a cloud if someone is new to that. Okay, so how you set up an account, how you create a EC2 instance on cloud, how you deploy Gremlin onto that EC2 instance, that we will try to see. And this is like, for example, now AWS, if you have to access, you need a free trial account. Okay, but in case like if you don't want to do that, like or you just want to learn and you don't want to do any hands-on, whatever we do after this, like after we set up our cloud, and after when we progress into our Kubernetes cluster, we will be using a local tool like a Minikube. It's called a Minikube. So you don't need to have cloud always. You can set up on your local machine itself, so that you don't need to create your cloud account and all. But obviously, for as a learning purpose, if someone is interested, we are covering that also, the AWS, so that you get an understanding how the AWS works and what are the initial uh, setup. We generally how the setup happens, okay, in AWS side. Then we will also, so if we see how we progress, so we generally progress from host to a Docker to a basically Docker, we say containers, to a Kubernetes cluster. So first we will, when we are speaking about the host, we will all learn about like how we set up and implement Gremlin onto a simple host machine, how you attack the host using different attacks. So see, in chaos engineering we use the word attack basically. So what do we mean by attacks is nothing but it's like we can say the experiments which we do and different injections or different faults which we inject into the system, that's called attack. So we will learn how what are the various attacks which we have, what are its significance, and how each attack can be uh, classified into different components which we can do. For example, if we speak about the latency attack or a black hole attack, the black hole attack is mainly used for dependent services. Similarly, if you speak about latency attack, you clearly target the DBs or databases or queue services when we come to latency attack. Now, if you have a shutdown attack, we look for disaster recovery systems. Like those level of experiments are planned using the shutdown attack and the and like now we also have a packet loss attack. Packet loss attacks are mainly we try to view the user experience or how the responses will change based on the packet loss, right? So to simulate those things, we have packet loss attack. So different attacks are there. So we'll try to see those in detail when we go to the host level. Now, after host, now we need to implement it for Docker or a container, right? So how do we do that? So that also we will learn, like how we set up Gremlin onto a Docker container and how you run our attacks on different containers which are in your system. Now, when we learn that, we will also learn Docker basics, like what's a Docker, what are containers, because you need to understand Docker containers and all before we go on to Kubernetes, because Kubernetes is built over the concept of containers. So we need to understand what are containers. So in that process, we will learn what's a Docker hub, how the images are being pulled from the Docker hub, and those images are converted into containers and how those run, right? So those details we will learn. And we will learn like how you deploy a Docker, create a container, right? So that's a good thing to learn, like how generally you create a container, because let's say you want to run some application and you want to install some application. So what you can do is you can easily install that application in a container, and once your work is done, you can delete the container, which makes your POC very easy for you, and you don't touch any other components which are there in the system. So it's better to know, it's good to know about the Docker containers and how you create a container and different Docker commands we will learn, right? Because in Docker itself, Docker has its own language. Okay, like for example, not like the C programming or programming language I'm saying about, but more sort of a Unix. Like for example, in Unix we have to make a directory, we have make dir command and all. Similarly, For Docker, we have some commands like docker run, docker stop, docker start, so all those. So basically to manage the containers, we have those commands. So we will also see those commands in action. Okay, so how to use those commands. Now, once we complete our Docker, so we have completed host, we have completed Docker container, then we will move on to the Kubernetes. So when we reach Kubernetes part, what mainly we will be doing is we will be deploying an application. So once first is we will set up our Kubernetes cluster, which is very easy for you. So once you start, once you learn, or once I show you how you do it, it's very easy. You will feel like Kubernetes is just a piece of cake. Okay, so you will learn that, like basically how you set up a Kubernetes cluster very easily, and also what are the some important Kubernetes commands. Like for example, if you have a lot of pods running, right, you need to get the status of the pods. If you want to describe a pod, if you want to get the logs of the pod, you want to analyze the pod. Like pod has different states, so why the pod goes into that state, and when we are attacking some pod, when the pod goes into that state, like how to bring it back, and those things. Like those are important things we will learn in the Kubernetes section. And also obviously how you deploy Gremlin into the Kubernetes cluster. So now we know how to deploy Kubernetes in Gremlin into a host, into a container, into a Kubernetes cluster. So this way we will proceed. Now when we learn Kubernetes, we will also, so mainly we will learn the kubectl commands, because that's a language which we use to communicate with the Kubernetes cluster. Okay, so we have kubectl commands, different important kubectl commands which we will learn, and even I will give you a list of commands also, like a cheat sheet, which will be useful for you later on when you are working on your own projects and all. It will be like more sort of easy for you to find those commands in that way. Then when we learn that, we'll also look into something called a Helm chart. So Helm charts are like in Docker we have Docker Hub. Similarly in Kubernetes we have Helm artifact hub. So here basically if you want an application which you want to install onto your Kubernetes cluster, you get that application in the artifact hub. So for example, if I want Gremlin, I want to install Gremlin onto my Kubernetes cluster. So I get that Gremlin image, or we can say the Gremlin file from the artifact hub. Now using this only, I will install Gremlin onto the Kubernetes cluster. So Helm makes our life very simple when we come into the Kubernetes cluster world to install applications and all into different services, different pods and all in that way. So we will learn this. We will learn what's a Helm. That time it will be more clear. Now when we speak, so now the setup is done. So now we are at a stage, we have our application. So what we will do now, we will deploy one demo application called microservices demo. So this is the application which, in this process we will learn also a little bit on GitHub, what is GitHub and how we some basics about GitHub, and then we will also see like how to deploy this application onto our Kubernetes cluster and run attacks onto this application. So you have a demo application on which you play around, or you study, I can say, or you experiment your chaos engineering activities on. Now this application we will use, it's a basic sock shop e-commerce application, and it is, if you see the application design, it is a microservice based application. So you have order microservice, payment, user, catalog, cart, shipping, and there is a queue, RabbitMQ. Then all the microservices are built on different programming languages, different DBs. Okay, so we will learn this, how it happens, like what are like some basics. So if you see now, there are a lot of things here, but if you see the prerequisites are none, because everything is being covered in this course itself. Okay, so you don't need to have any major prerequisites as such. Even coding language also, I will say, won't be required much, because everything is commands, and what all we are doing, we will be learning it, and I will be giving you the files also, so you can use it later, right? So even the commands and all, so you won't be needing anything from outside, all right? Everything is there in the course itself. Yeah, so once we deploy the application, we will be using this application to perform our experiments and all, to learn chaos engineering on. Now, once we have this, we will also set up the monitoring also, like Grafana. We will deploy Grafana. We will understand how we deploy Grafana onto our Kubernetes cluster with Prometheus, obviously. And we will also try to monitor our experiments onto Grafana and Prometheus. And then finally, once we have the monitoring, we understand the attacks, experiments, what's happening in chaos engineering, and different Gremlin components. So this is Gremlin, how the Gremlin dashboard looks like. what are the different options which Gremlin provides, Gremlin APIs, experiment scenarios. After we've complete that, we will move on to CI/CD. Like we will understand how we automate our CI/CD experiments or chaos experiments using Jenkins CI/CD pipeline, right? So this is how the things will progress one by one, and we will reach the automation section. So once we reach there, like we will be then looking into Chaos Mesh also. Chaos Mesh is a Kubernetes tool, again very similar to other tools like Litmus Chaos and all. So once you learn Chaos Mesh, it will be very easy for you to learn other tools also like Litmus Chaos and all. And it's an open source tool, because what I thought is when we are covering a paid tool, we should cover also one open source tool. So we will be trying to see how to set up Chaos Mesh, how to run some attacks on Chaos Mesh. That also we will be covering by the end. So that's how the course will proceed, and a brief overview of the course. If you have any questions, please proceed.
Uh, there are going to be so many types of attacks, right? When you say attack, it's a
Yeah.
simple word, but so many attacks. So how will you
Mhm.
narrow down?
Yeah, so see, currently Gremlin has 12 attacks. So it's not many attacks, because if you see the market conditions and the market research, if you do, these are the 12 attacks generally which will happen in the production, or the issues which will happen in production. And based on that only, Gremlin has decided onto these 12 attacks. So we will be learning all these 12 attacks, different scenarios where we will use these 12 attacks, and what are the components which you can run these attacks on. So in that way you will learn. So it's not that you will have to learn a lot of attacks which are there in the market, because it's more sort of like, see, the community, the chaos engineering is a very new concept. Okay, so people are building over it, so there is no proper reliable solution where people have really researched, and there's a big community on, okay, these are the attacks which we need. But Gremlin is a paid tool, and they have done an extensive research on that, and they have come up with these 12 attacks. Okay, so that we will learn.
Oh,
Krishna,
uh,
am I
yeah,
clear?
yeah.
Yeah, yeah.
One more thing is, like we already do load testing, stress testing, and all the soak
Mhm.
testing, right? So why do we need this chaos testing attack, like
Yeah, so we
chaos?
will learn that once we start our introductory module, right? It will be very clear to you why we require this one more testing, and especially, so the main answer to that is the objective. See, every testing has an objective. So performance has, let's say, objective of load and stability. We say our security has the security objective. So similarly, chaos engineering objective is mainly on focusing on the user experience and recovery. So that's a main, we can say, the goal of chaos engineering on improving your system's recovery rates and also the user experience. Okay, so that's what we will learn very extensively in the first module. We will be very clear like what it is.
Okay.
Like,
Krishna, just try
I have a
talk.
question. Like, are we
Yeah, Amol.
integrating any tool with this, like Gremlin, or else like we are just monitoring here?
No, so see, when we are deploying Gremlin onto our demo application, which I showed, right? So that demo application. So once we deploy Gremlin onto that demo application, we will run the attacks on that application. So we will see, like, for example, in that application, your catalog service, order service, and all, right? So how you attack those order services, and how you look for the problems, or how you monitor the services on Grafana, and also on the command, like on the non-GUI end, right? How you monitor those attacks, take up the logs, pick up the logs. So those we will see, Amol.
Okay.
Sorry, that was Venkat. I say Amol here. So I just trying to
Oh,
understand,
sorry.
like, yeah, no issues. We have a resiliency testing, right? I mean, we do the resiliency and failover as well, right? To the
Exactly.
existing applications where we perform different kind of failures, like, I mean, the with respect to cloud, if we talk about, like, I mean, on the microservices, right? Node base and all, like cross GC within a DC and other kind of failures as well, like database and all. So what is
Yeah.
the difference, like, I mean, with the chaos and the normal resiliency and failures we do? Because in that also we have different scenarios, right? Whenever required. So we do those kind of failures as well, either on load balancer side, or from the network side as well on the database layer and all. So yeah,
Yeah, right. So see now this it's more sort of see when like let's take this question one by one. When if I
yeah, yeah,
say
sure.
let's say resiliency versus chaos engineering. So see chaos engineering is a broader term which also covers resiliency. Okay, so as I said, so making your system reliable or
Yeah.
resilient is more about how, it's not see in failover it's mainly how your system will withstand any failure. So here we are not worried
Mm-hmm.
about withstanding. Like let your system fail. Okay, let your system fail, but when your system fails, how fast will it recover, right? Is it in 1 minute or 5 minutes or 10 minutes? So that's what chaos engineering mainly focuses on. So you have to reduce that 10 minutes to 1 minute. So that's our major
Okay.
goal, or we can say making our system more resilient to the failures, right? So that way you
Because
can clearly define a boundary between failover and chaos engineering, and also obviously user experience. So see what happens is when we model chaos engineering experiments and when we recommend the solutions to different problems, it's not only technical solution but also design solutions also, even processes. So design solutions in sense like for example like let's say your order service fails and my user is in the order page, he's not able to order the order anything because of that order service failure. So what I will do is when the order
uh,
service fails, I will create a redirection where maybe the user will go directly to the some offer page where he will play some game or
mhm,
something like a spin a wheel or something, he will get a coupon code, and in that specific time period my system will recover. So my user will never
okay.
know that something happened to the system in that specific time. Okay, so in that way what we are doing is we are protecting our customer goodwill also, and we are keeping our business continuity, right? So yeah, so this is also a recommended solution which we do in chaos, like the design changes, right? But majorly yes, it's a technical fix which we do. So for example, as I said, if it's taking 10 minutes for your pods to come up, we should bring it
Yeah.
down to 1 minute or half minute, which doesn't affect our business a lot, right? Yeah, so that way, so I hope you're clear, Amol. So what's the
Yeah, yeah.
difference?
Yeah, with the resiliency also, right? I mean, we do check for the RT and RPO, right? I mean, what is the SLA
Yes.
for that? But yeah,
Hmm.
so we are saying like, with the chaos, when we are looking for the fixes and I mean, if there are any kind of a design change or something, so those as well, right? Like to
Exactly. Hmm.
reduce the timelines, like if it's taking more time, so how we can do that, correct? So,
Yeah.
will it
So
help
because
that?
sometimes, right, sometimes what happens, right? Like if you have a system which is taking 5 minutes
Mhm.
to recover, now it
All
would
right.
be maybe the design itself which is taking that much time, and there is no way
Correct.
we can bring it down to maybe 30 seconds and all. So what we
Yeah,
need to
yeah.
do is, yeah, for that 5 minutes we have to hold our customer somehow. Okay,
Correct.
so
Yeah,
we make the design changes, but that's a rare case. I will not say always, maybe 5
yeah.
percentage
Yeah.
of the time it will happen,
Right.
but 95% we will have a technical fix. Okay, so right.
Right.
Yeah, can you
Thank
give
you,
like
Ashwin.
an example, like holding the goodwill of the customer? Like, can you give like simple example or anything like that?
So as I said currently, which I said, that's an example where you keep your customer. See, it's your fault. Your system is failing, so you give the customer an offer, right? A small coupon code or something, which
Yeah,
is basically like we are giving value for his time in a sense. So you are giving a coupon code to him, so he will not like, for example, if Amazon is failing, he will go to Flipkart, right? So we don't want to do that. We want to hold him into our application itself. So what we do, we redirect him to a some interactive page where he gets some value out of it. So he will remain in that application itself, and
Okay.
as soon as it's done, our system is recovered, we will redirect him back to the same page where he was ordering. So the journey continues. So
oh,
that way, yeah. So these are some situations which you can model. Just an example. So how will you test this? You can test it only using chaos engineering. Okay, so these things like the recovery, whether the redirection is happening properly when your system is failing. So those things. Okay, so that all happens in the chaos engineering only. You cannot do this specific type of activity on any other using any other tool. Okay, so that's a major advantage which chaos engineering gives you, right? And also why we use a tool? See, obviously different attacks are there. You can create all these attacks as custom attacks using code, right? But like not all are good at coding, right? In a Go programming or Java programming and all. So we have different tools which provide all these different types of attacks at a click. So that makes our life simpler. It's more sort of like people might ask like, why do we need Jmeter? Because I can create traffic but just by writing some 10 or 15 lines of Python code, right? But still we use Jmeter because it makes our life simpler by giving everything of performance what is required in a one tool. Similarly, why we need Gremlin is we need all those things what we do in chaos engineering all in one tool, and they are experts in that. So we use that tool, right? Yeah, Arun, go ahead. You had some question. Arun, had any question?
Oh, no, no.
Yeah, okay.
Uh,
Kiran,
I have a
yeah,
question
go
on
ahead.
tool evaluation.
Oh, okay. Uma, yeah,
Yeah.
go ahead.
So we do have different tools on the market, right, for the chaos engineering, and
Mhm.
each tool have their own limitations. Like
Exactly.
some they will be working on cloud, and some they will be working on premise.
Mhm.
So do you
Mhm.
suggest any tool that works on all criteria? Like it should be working on cloud, on premise. So do you when an organization
Yeah.
is evaluating
Mhm.
and do want to do some POC to satisfy all these
Mhm.
requirements, what do you suggest on that?
Yeah. Right. So see, there if we classify the tools which are there in the market for chaos engineering, which are reliable, because I'm specifically quoting this word reliable is because the open source tool which are there are a lot of tools in the market which are not proven or reliable and which will spoil your systems when you run some attacks. Okay, so it's very difficult to bring it back to the normal state when we use some open source randomly. So if we speak about the market, two classifications, one is paid and open source. In that, if we speak about an all-rounder, obviously it comes in with Gremlin only. Okay, so Gremlin basically it's a very easy tool to implement and it works on all the systems, in bare metal, in cloud, in containers. So all the systems Gremlin you can deploy, even kiosk machines, POS machines, right? For testing those you can use Gremlin. Now coming to the open source, so majorly I will say the tools which are available for in the open source section, like for example which works on everything, is chaos toolkit and some other tools. But chaos toolkit is also not that reliable as per my experience, because when we had used it, we had faced a lot of issues setting it up, because it's a little complicated. It's not that very easy. You need to understand the programming. It's basically on Python, so you need to know Python, like how to write a driver code and all. So it's a little complicated on the chaos toolkit side. Now if we come to Kubernetes as such, we have a lot of good open source tools like chaos mesh and litmus chaos, which is very good tools available in the market. But the limitation what they have is they work only on Kubernetes cluster and host. So you cannot go beyond that. Okay, so if you have a Kubernetes, then only this chaos mesh will work, or litmus chaos can be used. Okay, so these are the limitations. But yeah, so if I want to call out as an all-rounder, obviously Gremlin is a very reliable and good tool, but it's a paid one. Yeah, we have to live with it. Otherwise, if you want to have an all-rounder tool, but yeah, if based on your system, if you want to choose, if you have a Kubernetes cloud and all, go ahead with Chaos Mesh or Litmus, because both are similar. It's like if you see Litmus Chaos and Chaos Mesh are like brothers. Okay, if you see, it's very similar. It's more sort of like they're built on the same kernel or same code base. It will be very easy for you to learn. If you learn one, the other one will be easy. I hope that answers the question, Uma.
Yeah, thank you, Vishnu.
Yeah. Now, if you're using AWS, again, you have AWS FIS. So every cloud also have their own chaos tools nowadays. We have Azure Chaos also. Similarly, so yeah, so based on cloud also, but again, they are paid. Okay, so FIS is paid. Azure Chaos Studio is also paid. So yeah, they are paid ones. So we will learn, like we have a section where we speak about the tool limitations, tool comparisons, why we choose these tools and all. So that time it will be very clear. Like we will compare some 10, 12 tools with each other, and we will see what are the limitations of each of them. Like what are the things which they provide extra, which one to choose in which condition, which situation. We will discuss that. Kiran, please go ahead.
Yeah, Vishnu.
Yeah.
Coming back to our previous discussion, we are talking about the objective of chaos engineering or chaos
Yeah.
test, right? Why we are doing. So most of the topics that you have covered, we are doing failover testing and disaster recovery testing. Did I miss something
Mhm.
here, or?
Right. So see, disaster recovery. Okay, let's come to that question. So now see, when we speak about failure of, I have already explained, I guess, to Krishna or Amol. Yeah, Amol, I guess. So see, when we come to failover, it's more about how your system will withstand any failure. Okay. So failover testing is more about the withstanding of any failure, or how your system will still remain active. Okay. When some fault will be triggered into your system, but chaos engineering is more about how well your system will recover, how will the user experience will be there. So those experiments which you do is on the like on the chaos engineering side. Now the disaster recovery which you said is just a subset of that. Subset is means like it's just a small part of that recovery, right? Because the recovery situation doesn't come only from a disaster; it comes from different situations, right? So chaos engineering covers all those situations. I hope you get my point, right?
Yeah, yeah. So just like you mentioned, we are just engaging the customer instead of going to competitors or losing the customer.
So that is one objective.
One
But the
object.
main objective is recovery. Your
Yeah,
system has to
recover.
recover as fast as possible, so that
Right.
so we study that, we understand our system, we inject chaos into the system, means like purposeful faults into the system, and then we will study how fast your system is recovering, what are the configurations which we need to tweak. See, because recovery is also very